This is going to be the first of two videos on inheritance in C++. So with C++, we've created classes. That's what we've just been working on. So once we have a class, we have the ability to create other classes based on the classes we already have. This turns out to be pretty convenient. So with that, we can do more work without having to do more code, right? We can take the same code and reuse it. And when we reuse code, it's not only more efficient, it also leads to less errors. If we have code that is already correct and we use it, then it's not going to introduce new errors later on in the code. Okay. So two basic ways we can do this. The first is through inheritance, which is what we're talking about here. And that models an is a relationship. So a square is a rectangle. Um, an employee is a person. A full-time employee is an employee, things like that. So the other way to do it's through composition or aggregation, and that's a has a relationship where you have different components that you aggregate together. So a car has a engine, a car has a wheel, whatever. Okay. So what we're talking about is inheritance in this chapter. Okay. So where this comes up. So let's say that, and this is kind of a forced example, but let's say that we've already created a person class. The person class has a name attribute, it has a get name and a set name. It's all ready to go. It's been tested. So we want to create a part-time employee class. Rather than adding name and its accessor and mutator to the new class, we're just going to create the class based on the person class. So when we create a new part-time employee, it will have a name. It will be able to access um, the get name and the set name. Okay. So that's going to make things quicker for us. And there's a lot of terminology that gets used, and it means the same thing. So the we would say that the new class that we're creating, so the part-time employee class, inherits from the person class. Okay. We could also say that, and we'll see how this makes sense later, that the part-time employee class is a specialization of the person class. It has more information. Okay. And other ways to think of this, we refer to the person class as the base class and the part-time employee as the derived class. We could also refer to the person class as the super class or the parent class, and the part-time employee class would be the subclass or the child class. Okay. So inheritance comes in two basic flavors, and that we can do single inheritance where there's only one parent that we're inheriting from, which is the most straightforward, or we can do multiple inheritance where there can be more than one class that we can inherit from. And there's no practical limit to that. Okay. So it turns out that multiple inheritance can get a bit tricky and leads to a lot of coding errors. We're not talking about it in this video. And in fact, languages that have derived from C++, basically Java and C Sharp, or at least in particular, those languages have gotten rid of this idea of multiple inheritance because it can be problematic. Okay. And they have other ways to get around that problem. So instead of just inheriting one time, we can have these whole hierarchies of inheritance. So for example, we can create a shape class, and then from the shape class, we can derive two subclasses, circle and rectangle. Okay. And in that case, a circle is a shape and a rectangle is a shape. Then we can further specialize the rectangle class into a square class. Okay. So a square is a rectangle and a rectangle is a shape. Okay. I'm not going to show the UML diagrams today, but basically you can connect these hierarchies through an open triangle and a line down to another class diagram box. And we'll look at that at some point. Okay. So the basic syntax we're going to use here when we're going to create this new class. Okay. So we have the class name is the new class that we're creating, colon. Then we have the member access specifier. Okay, so this is going to be whether it's public, private, or protected. We'll talk about that just in a second. Okay, and then the base class name. Okay, so if we were doing a part-time employee class, we'd say class part-time employee colon public or private person. Okay, we then have the member list, okay, whatever we're adding to it. So this public, private, or protected, we haven't talked about protected yet, and we won't today, but it comes down to how you're going to deal with the public members. So as strange as it seems, the private members of the base class or the superclass. Okay, so in our example, the person class, the name, that's private. Okay, you can't get to that from the derived class directly, no matter what. Okay, so the public or private here relate to the public members of the class. So if we inherit with public inheritance, then I can get from the part-time employee class to the get name and the set name. Okay. If I do private, I can't. So for that reason, even though private is the default, if you don't put anything, public is what we're always going to do, at least in this class. Okay. There are examples where you wouldn't, but in the way we're conceiving of inheritance, public makes the most sense. Okay. So again, whatever's private in the superclass is going to remain private no matter what. But if we declare it as public inheritance, then whatever's public in the superclass will be available to the subclasses. Okay. So the public members of the base class are what we're going to be able to get to. Okay. But keep in mind, a instance of the part-time employee class will have a name attribute. It just can't get to it directly, which is a little weird. Okay. So the derived class often, in fact, almost always, that's why we do it, that's why we call it a specialization, it's gonna add more stuff, right? It's gonna add more member data, okay, more variables, okay? Um, and that's how we add more information. So in our case, we're adding to the person class a employee ID number, a hours worked, salary, whatever else we need, okay? It's also going to add new functions, typically, okay? At least accessors and mutators for the new items that it's adding, the new member data it's adding, okay? It's also pretty common that the derived class is going to redefine public functions from the base class, okay? So if there's a print function in the base class, we can redefine that print function in the subclass, okay? To redefine it has to have the same name and the same number and type of parameters, okay? And the compiler keeps track of things for us. So if we have, for example, the shape example, if we are in a square object and call the print function, it will call the square object's version of the print function, assuming there is one. If not, it will call the rectangle, okay? If we're in a rectangle object, it will call the rectangle version of the print function, if there is one. Then if not, it would call the shape, okay? So it keeps track of what it is and how it works, okay? And again, I think the biggest thing here to remember is that if you declare it as public or private, doesn't matter. You can't directly get to private things in the superclass or the base class. Okay. We'll see this in an example. Okay. So let's look if we have a rectangle that we're going to specialize into a box. Rectangle 2-dimension, box is 3-dimension. Okay. So let me go ahead and share over here. That's not what I wanted to do. I want to share. Why am I not sharing? There we go. Okay, so hopefully this is the size that's decent for you. So I'm going to put a little test program in here. So remember when we're doing a class, what we normally want to do, we want to create it as a separate file and then include it. That's probably the best way to go. Certainly going forward it is. But if I want to run a test program, I'm going to need to have the include IOStream, the username so standard. Well, in fact, if I'm going to use, and I'm going to use cout and in my print statement, I need these anyway. Okay, so these need to be there. Okay. So our class here, the first one, this is our base class, or super class, whatever you want to call it, parent class is called rectangle type. Okay. And let's go to the bottom. I always like to start there with what's private. So this is what each rectangle knows and keeps track of. Okay. So the rectangle is going to keep track of length and width, both of which are doubles. Okay. So the next thing I like to look at, and these are at the bottom, oddly enough, of the way we typically put them together, although it doesn't really matter, are the constructors. So this first is our default constructor. If they just say a new rectangle type, okay, we're going to set the length and the width both equal to 0. Okay. Then we have another rectangle type that takes both, takes two doubles, L and W, we'll call it. And then we already have a function. We've talked about this before. We already have a function that tests to make sure that these are positive values greater than 0, greater than or equal to 0. And if not, it sets them to 0. So rather than do all that logic again, I'm just going to call my set dimension on L and W. Okay. This should all be reviewed. None of this is new. This is just creating a class. Okay. So I can go back to the top and look at the ones that we're adding. Okay. So we start with our accessors. This example is in the book, but it's in a different order a little bit. So I kind of do things my own way. So I've got the accessors here, the get length. Okay. It returns a double. It's a constant function because we're not changing anything. It's going to return the length. The get width returns width, same way. The mutators, the book decides to do it 2 and 1, which is fine. So we're going to set both the length and the width in one function instead of having a set length and set width. So that's fine, but they're still mutate. It's a kind of a multi-mutator, okay? So here I'm just ensuring that the length is greater than or equal to 0. Then I'm setting the length equal to that L. If not, I'm setting it to 0. The same thing for the width, okay? Other functions that we have an area function, which returns the length times the width. Basic enough. We have a perimeter function, which is how far, if you had to walk around the rectangle, what would be. So that's 2 times the length plus 2 times the width, or length plus width plus width. That makes you happy. Okay. And then we have a print function that's just going to print out a new line character, the length tab, the length variable, then same thing for the width. Okay, pretty basic. Okay, and then those are constructors we've already talked about. So now let's say we want to add that third dimension. We've got a length and a width. We want to add a height, okay, to make a box. Okay, so we start with the declaration of our inheritance. So I have the class box type colon. I want this public. I want to be able to get to the set dimension and the get length and the get width and the area and all that stuff. Okay, so to do that, I have to set it as public. And rectangle type says that box type inherits from rectangle type. Okay, so as always, I'm going to go to the bottom to look at what we're adding. So the data that we're adding here is a double called height. Okay, pretty straightforward. So let's look at the constructors. That's the next interesting thing. Okay, so because a box type can't directly access the private data, the length and the width of the rectangle type, we have to call rectangle type's constructor, okay, every time in a subclass. So these are one of these rituals of programming I talk about. When you create a constructor for a base class, it has to call the superclass constructor, okay? If we're in a chain, if the rectangle type derived from the shape class, box type doesn't have to worry about that. Box type would call the rectangle type constructor. The rectangle type constructor would call the shape type constructor, okay? So we have our default constructor. We're setting all to 0, box type. We have a colon. It's usually down on the next line for some reason. Doesn't have to be, though. We're going to call that rectangle type with no parameters. Okay, so that's going to call the version of the rectangle type constructor that set the length equal to 0 and the width equal to 0. Okay, so the length and the width are dealt with, but the height's not. So we're left with a height equal to 0. Okay, the other example is a little more complicated in that when we call this new box, okay, we have to specify all of the parameters that box needs and the parameters that rectangle needs, all three in one spot, okay? So we're gonna have a double L, double W, and a double H, okay? So we're gonna pass off whichever of those we can to the base class. So we're gonna say rectangle, so again, colon, rectangle type LW. They're going to go up. It's going to test, see if they're greater than 0. It's going to set those properly. Okay. We cannot directly access length and width, so we have to go through this process. Okay. So the other thing we have here to deal with then is the h, the height. Okay. So we're going to deal with the added height, the new field. So we're going to say if it's greater than or equal to 0, then we're going to set it equal to h. If not, we set it equal to 0. Okay. So that's pretty basic. So let's look at the other functions that we need to deal with here. Okay. So the first, we have our accessor. We have the get height. We can call get length and get width already. We don't have to add them. Those are public functions, so we can get to them just fine. Okay. So we're just going to have to deal with what's addition. So we have to do the get height. Okay. As far as the set dimension goes, the set dimension that's in the rectangle class only deals with 2 dimensions. Okay. So we have to add one more dimension. Okay. So what we're doing here, again, the set dimension is going to take a length and a width and a height. Okay. I can deal with the height, no problem there. Okay. But what I can't deal with is the length and the width. Typically, there'll be mutator functions for a get length and get width, but we don't have that in this case. So instead, I'm going to have to call the rectangle type version of set dimension, setting along the length and the width. So to do that, I do the namespace typing. Okay. Notice that I'm doing all of my functions in line inside of the class definition. You could also do them below if you wanted, like the book does. Okay. So I've got my rectangle type set dimension. That's saying specifically, don't call the set dimension we're defining, call the rectangle type set dimension. Okay. That'll take care of the length and the width. Then I'll take care of the height here. Okay. So the next function is the area. And I'll have to admit, the first time I did this video, I started looking at the area and it totally confused me because I was thinking, what's the difference between the area of a box and the volume? Well, it turns out this is probably not the best named function because what we're talking about here is the surface area. Okay, so the surface area of a box then is equal to each of the faces of the circle. Okay. So it's 6 times basically the area. Okay, 6 times the length times the height. And I'm still not 100% sure that's I'd have to think about that a little bit more mathematically correct. But that's what we're dealing with. Okay, we're dealing with the box has 6 sides, and this is incomplete to fix that. But that's what we're thinking about. If you think about a dice or a die, 6-sided die, okay, that's a box and it has 6 faces. But what I'm not accounting for here, this assumes that they're square and all 6 sides are the same, and they're not because it's a box. Okay, so I would have to go through and figure out there'll be 2 where the area will be length times width, and 2 where it's length times height, and 2 where it's height times width. So that's what I've done incorrectly there. Okay. Yeah, I think that I've got it reasoned correctly. The code's not correct, but that's correct. Okay. The volume then is pretty straightforward, but it's going to take the get length times the get width times the height. Okay. I could also do the area function times height, and that would be fine. Okay. And then the print, I'm just adding a new line character, and then the length, the width, and the height for the new one. Okay. So that's all that we're doing here. And then at the bottom, I'm testing it out. Okay. So let's actually not leave that. Let's not take the easy way out. Let's go ahead and fix this. Okay. So let's just do a little more reasoning right here. So we're going to have 6 panels, basically. Okay, or 6 faces of the box. Again, think of dice. Okay. So we're going to have 2 are going to be the length times width. Okay. And we're going to have 2 that are the length times the height. And we're going to have 2 that are the height times the width. Okay. So the length times the width, I'm also calling area from area, which is not, it's a recursive call that I don't want. Okay. So I don't know if this may be a really ugly equation, but let's just see what we've got here. So I'm going to return, first one is going to be 2 times get length times get width plus 2 times get length times height, I get height directly, plus 2 times get, I've got height there, it's the same way, height times get. That's kind of ugly. You may want to break it up, but that should be the correct idea. Okay. And then to test it out, since I haven't tested my rectangle type, what I really need to do, but I'm not going to in the video, it's left to an exercise for the viewer, is test all of those functions, both constructors, check all the accessors, mutators, other functions for rectangle first, and then for box type. Okay. I'm going to do an abbreviated version here. Okay. And I'm going to create first my rectangle type R. It takes 2 parameters. I have my box type B. It takes 3 parameters. Okay. Then I'm just going to print each of those. Okay. See if that much works. And the only thing that changes my area, see if I've messed things up there. Nope, things look okay. And there we're good. So we have, notice that correctly, the rectangle type R called the print with 2, and the box type B with called the correct version of print for it. Okay. So again, in my test program, I would want to further test things out. Okay, so I could just do one more here. I could do a cout r dot area, cout b dot area. Both of those work in some way. We'd have to calculate what those actual values are. Okay, and then we could also cout b dot volume. Just make sure the functions look correct. Okay. Okay. I mean, they look reasonable for sure. So we know correct that the area on the first one, 4 times 3 is 12, so that is correct. And the other, we would have to calculate, okay, to see if it's correct. Okay. We'd actually know that the volume is correct because 6 times 5 is 30 and 30 times 4 is 120. So those look okay. And they certainly look reasonable values. Again, what I just did is not a test. A test would be to actually calculate outside of the program, calculator by hand, Excel, what your value should be and test all of your functions. Okay. So that's our introduction to inheritance. It's a very powerful tool. Okay. We're able to create new classes based on existing classes, specialize those classes, and go from there. Okay. So we'll do more with this. The next video will contain more information about inheritance and how we can use it.